Okay, today we're looking into the probability tables. They sometimes called also Karno map. In the previous curriculum they were called Karno maps, now they call probability tables, and conditional probability. Conditional probability is the hardest part for students. Usually students do the worst on the questions with conditional probability, I mean on the year 12 exams and in general. So, probability tables. Let's again consider some example. Let's say we have class of 25 students and let's say 15 do methods and 8 do one of the sciences and 5 don't do any. Don't do methods, don't do.
That's not possible. That adds up to 28.
What do you mean not possible?
Isn't it 2?
Some people can do both.
Yeah.
Some people can do both. So how we can work out how many people doing both? If we add those, we get 28. 28 minus 25, 3. That means 3 doing both methods and science. Make sense?
Yes.
So let's represent this situation on the Venn diagram first. So that's math, that's science. So we have 3 doing both. This will be methods only.
12.
12. How many science only? 5. And we have 5 here.
That adds up to 25.
The same, which adds up to 25. Now we can represent the same information using probability table. Probability table.
Oh, it has to like fill the gaps like this.
We have math, not math. Doing science, not science.
No, you're doing math.
Yeah, I don't get it.
So total, we have 25 students.
I like it. This makes me feel like 3.
25 students. This is doing both math and science. Math altogether we have
12.
we have 15.
So 12.
Math we doing 15 students. So these students who doing math but not doing science. So
Jesse.
12.
Is Jesse doing math?
Now we have students who doing science, not doing math. We have 5, and altogether we have 8 doing science. So not doing math. There are 15 students doing math. So how many not doing math?
10.
10. So we have 5 students, those not doing math, not doing science. So we have 17 here. So all numbers should add up. Horizontal should add up to 8, this should add up to 17, this adds up to 25, and vertically they should add up as well.
Yeah.
Now, if we represent now that not with just numbers, but with the probabilities. So we will be taken out of 25, so this always will be 1. Total probability is 1. This we will have 3 on 25. This will be 5 on 25, which is 1/5. This is 8 on 25. This 12 on 25, that will be 1/5 as well. 17 out of 25. This will be 3/5, and that probability will be 2/5. Usually in the questions involving probability table, you will have 3 numbers, and you will require to work out others. So let's consider the next example. If we have
Raining and not raining.
that probability students are playing footy, not footy, soccer,
Yeah.
not soccer.
What's the
One's footy, one's soccer, man.
it's football actually.
And the probability that randomly chosen student are playing soccer will be 0.6.
What?
Probability that students are not playing student not playing soccer, not footy, let's say will be 0.1. 0.1. And students probability the student play both will be 0.2.
That's lucky card at time.
That's what's given. We need to work out all other probabilities. So total probability should add up to 1.
Can't do it.
And yes, if it's 1, what should be here?
0.4.
0.4. Because that should add up to 1. What should be here?
0.4.
Yeah.
0.4. So what should be here?
0.5.
0.5. What should be here?
0.3.
0.3. And here?
0.5.
0.5.
Sorry.
What if you had the,
Got that out. Got that out.
what if you so you did 0.6, 0.1? What if you put another number in the bottom corner, on the bottom left corner? Would you still you wouldn't be able to do that, would you?
In which, in the where?
In the footy, in the total for footy.
Total for footy, but if I will put this number different, but then I will need to change other numbers as well.
No, if you didn't add the 0.2 and you only put the at the bottom, only put a number at the bottom for your 3 numbers. You know how you added 3 numbers?
Yeah,
What
but
if
it always will be 3 numbers from which you can work out all, because you always, these 2 will add up to these 2 adds up to these 2 adds up to here, adds up to these 2 adds up to these 2 adds up to 1.
Alright.
It's always will be, so you can just do in your fraction or decimals work, you can work it out.
Yeah.
Make sense?
Yeah.
Now, conditional probability.
What? I thought that was conditional.
That was probability tables. Now, conditional probability. Notation. Notation is probability A given B.
Oh, yeah.
We read this probability A given B. And by definition, it's equal probability of A intersection B over probability B. That is definition of the conditional probability, probability A given B. What does it actually mean? Let's find probability, returning to this situation, let's find the probability that students are doing science if given that student doing math. So we need to find probability science given math. When we say given math, that means we definitely know that student doing math. That means our whole sample space now limited only to math. Everything that's not here gone. That's our all
Facts, brother.
sample space. So how many doing
1/5.
science? We have 3 out of 15. So intersection is 3
About a fifth, I think.
over 15, probability equal 1/5. So when we're dealing with conditional probability, we limiting the whole sample space only to given event. Only to given event. And sometimes students, the wording of the questions might be in that way, the student don't identify that it is actually conditional probability. So you need to read questions properly. So let's do some practice.
So where's the outro? The outro.